Okay, so probability and chance, this is the first class. So probability describes the likelihood of something occurring, and we normally describe it along a continuum or a line or a spectrum that ranges from impossible all the way down to certain. Now in the middle then we have 50-50 chance. Okay, if we're describing something that occurs between impossible and 50-50, we say it's unlikely. And if we're describing something between 50-50 and certain, we say that the probability of occurring is likely. So examples of things that are impossible to occur. You might say it's impossible to go back in time, so the probability of you going back in time is impossible. Things that are definitely going to happen. So the probability of you getting older is definitely going to happen. The probability of you getting homework in maths class is likely, but not necessarily certain. And the probability of you having a free class instead of me showing up is unlikely, though not impossible. So let's have a look at some questions, and we'll see can we put the probability of these on their relative position on the scale. So first off, what is the probability that tomorrow you'll be living in the year 2010? Now we know that's impossible because you can't go back in time. So we would call that impossible. Second of all, what's the probability that the coronavirus will disappear in a week's time? Now, it's not impossible, it's just very, very unlikely. So we describe the probability that the coronavirus would disappear as just unlikely. Okay, what is the probability that you'll be a day older tomorrow? Well, that's 100% certain, so we would describe that as certain. And the last one, what's the probability that it will rain tomorrow? Now, it's not certain, it's not 50-50, it's likely. And it may be close to certain, but it's not a definite fact that it's going to rain tomorrow. Okay, now we normally write probability as fractions, so we'll do the formula, and we'll do a couple of questions on how to calculate probabilities or chance as fractions. And the formula, first of all, we need these answers in fraction form. Now, on this line here with impossible, certain, 50-50 and the other two, if it's impossible, we say the probability of it occurring is 0. If it's certain, we say the probability of it occurring is 1. And if it's 50-50, then the probability of it occurring is 1/2. So any fraction between 0 and 1 can describe the probability or the chance of something occurring. And here's how we calculate it. We look at the total number of outcomes. So that's all of the possible things that could occur when an event occurs. That will go underneath the line. And then the ones that we're looking at, the total number of desired outcomes will go on top. Now, that might not seem that clear right now, but with experience you'll understand what I mean with that. So, calculation 1. A die is thrown. So a die is just a dice. It's a singular for dice. Single die, plural dice. What is the probability of it landing on a 1? So our formula is that. Now, desired outcomes. We're looking for the probability when it lands on a 1. So there's only one outcome, that it lands on the number 1. But a dice has, or a die has 6 sides. So that means the probability of it landing on a 1 is 1, because that's the number of sides that we want it to land on, or we're examining, all over a total number of 6 sides. Okay, example 2. What's the probability of the die landing on an even number? So we stick with our formula again, right? The probability is the number of desired outcomes over the total number of outcomes. So there are 3 possible even numbers, number 2, number 4, and number 6, that it can land on. So there are 3 desired outcomes for us out of a grand total of 6 possible sides. And when you cut that fraction down, you see the probability is 1/2 for when you throw a die for it to land on an even number. Example 3. If a card is drawn from a pack of cards, alright, so there are 52 cards in a pack. There are 4 suits in a pack, diamonds, hearts, spades, and clubs, and there are 13 cards in each pack. What we're looking for is what is the probability of drawing an ace. So if we think about our formula, how many aces are in the pack? There are 4. Ace of hearts, ace of spades, ace of diamonds, and ace of clubs. And there's a grand total of 52 cards. So the probability is a possible of 4 out of a grand total of 52. And when we cut that fraction down by dividing the top and the bottom by 4, we get 1 out of 13 in the smallest equivalent fraction. All right. A card is drawn from a pack. What's the probability of drawing a heart? So that's the ace of hearts, the 2 of hearts, the 3 of hearts, so on and so forth. Now, there are 13 hearts in a pack. There are 52 cards in total, so the probability of drawing a heart is 13 over 52. And when we cut that down, it's 1 over 4. Okay, that was a quick recap of probability and chance, and you should have homework on that also too, gents.